Questions 21 through 25 on the 2020 Grade 11 Fermat Math Contest. In the diagram, the central circle contains the number 36. Positive integers are to be written in the 8 empty circles, one number in each circle, so that the product of the 3 integers along any straight line is 2592. If the 9 integers in the circles must all be different, what is the largest possible sum of these 9 integers? Well, if we have, let's say, A and B, and we want to get a product of 2592, that basically means that A times 36 times B has to be equal to 2592. So whatever two numbers we have, A and B, that multiplied by 36 has to be equal to 2592. So AB has got to be 2592 divided by 36. And that is 72. So any two numbers, this one and this one, or this one and this one, any two numbers have to multiply together to get 72. Okay, I think what will be very beneficial is to get the list of the prime factors, or not necessarily even the prime factors, just the divisors is good enough of 72. So what are the divisors of 72? Well, the prime factorization is 2 to the power of 3 times 3 to the power of 2. So that means there are 3 plus 1 times 2 plus 1 factors, so 4 times 3. So there's 12 divisors. Divisors is a better word to use here. So I think I can list them. Let's see. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. These are my divisors of 72. So, as you can clearly see, we can easily make a list of two numbers that add or multiply together to give 72. 1 and 72, that'll work. 2 and 36, 3 and 24, 4 and 18, 6 and 12, and finally 8 and 9. All of these would work to multiply together to give 72. But we have already selected the 36, and all these numbers have to be different. So 36 cannot be selected, so this one is gone. That pair cannot be used. So from the remaining 10 numbers, I've got to choose 8, because there's 8 that have to go in there. Okay, let's do it in a way that we get the largest possible sum. So what is the sum? 1 and 72 is the sum of 73. This is a sum of 27. 4 and 18, 22. 6 and 12 is 18, and 8 and 9 is a sum of 17. Okay, so if I want the largest sum, I'm going to choose this, this, and this. Those ones. And therefore my sum would be this, plus this, plus this, plus this. And don't forget this 36 in the middle, because we want the sum of all the 9 integers. So 73 plus 27 plus 22 plus 18 and plus that 36. When you do that math, you get 176. And therefore number 21, the answer is B. Suppose that x and y are real numbers and satisfy these two equations. What is the possible value for x plus y? Quite a few ways of doing this question. I'll just do it a relatively straightforward way. One thing that we're going to use again and again in this question is the fact that x plus y squared is x squared plus 2xy plus y squared. Because these look similar. They're not identical to that, but they're similar, so we can manipulate them a little bit. The first one, x squared plus 3xy plus y squared is equal to 909. I can make it look like that pretty easily. Just break up the 3xy into 2xy plus y squared plus xy. And there we go. And then this factors, of course, into my x plus y squared. And the rest is the same. And then this one here, I'm pretty sure I can make it look similar. That is 3x squared plus xy plus 3y squared is equal to 1287. That looks a lot like 3 times this. So if I did that, the middle coefficient would be 6xy, right? So it would be 3x squared plus 6xy plus 3y squared. But then I only have a y, so I've got to subtract a 5xy. So that's a good way of manipulating that one. So therefore this just becomes 3 times x plus y squared. Yeah, and you can just compare that to that. And then I've got this minus 5xy is equal to 1287. All right, so I call this, how do you want to do this? Call this equation 1 and call this equation 2. That should be good enough. And now let's combine them. I'm going to do 5 times equation 1, and then I'm going to add it to just equation 2 by itself. So that means 5 times x plus y squared plus 5xy. Plus 3 times x plus y squared minus 5xy. And then the numbers are 5 times 909 plus 1287. All right, as planned, those cancel. And then this combined with that becomes just 8 times x plus y squared. And then these numbers, when you crunch out those numbers, you get 5832. 5832. Divide through by 8 and you get x plus y squared is equal to 729. Take the square root of both sides and we get x plus y is equal to plus or minus 27. And one of those is answer choice A for number 22. There are real numbers a and b for which the function f has the properties that f at x is equal to ax plus b for all real numbers x, and f at bx plus a is equal to x for all real numbers x. What is the value of a plus b? F at x is equal to ax plus b, and f at bx plus a is equal to x. So whatever goes in here, you substitute into there. So that means that f at bx plus a would be a times whatever is in the bracket here, you would put here. So instead of x, this time you put bx plus a, and then plus b. And they've told me that this is equal to x. So on this side, just put x. And then let's expand this abx plus a squared plus b. Okay, now let's compare. This coefficient is 1. So that basically means that ab is equal to 1. Those coefficients have to match. And then this part has got to be 0 because there is no constant term on the other side. So a squared plus b is equal to 0. Now at this point, I'm really just going to do this by inspection, just by looking at it and plugging in some numbers. First I try 0 and 0, right? If this is 0 and this is 0, that would work for this guy. But then up here, it would become 0 times 0, which is not 1, so that doesn't work. How about 1 and 1? 1 and 1 doesn't give me 0. How do I get 0 there? The only way I think is 1 and negative 1, or negative 1 and 1. Let's try 1 and negative 1. 1 squared minus 1, that would indeed give me 0. But then AB would be 1 times negative 1, which is negative 1. So that leaves me with the only other possibility, which is A is negative 1 and B is negative 1. So that means AB would be negative 1 times negative 1, which is 1, so that works. And then A squared plus B, that would be negative 1 squared plus negative 1. And that's going to be 1 minus 1, which is indeed 0. Okay, that works. So what do they want? They just want A plus B. Okay, well, A plus B is going to be negative 1 minus 1, which is negative 2. Number 23, the answer is E. In the diagram, the circle with center X is tangent to the largest circle and passes through the center of the largest circle. The circles with centers Y and Z are each tangent to the other 3 circles as shown. The circle with center X has radius 1. The circles with centers Y and Z each have radius R. The value of R is closest to. Let's draw some helpful lines to figure this question out. And the first one, I'm going to just connect those 2 centers. The next one, I'm going to connect these two and then these two. And then I'm going to draw a line all the way through that to that point. And I think that should be it. One more from this point to that center. And I think that should be it. All right, so here we go with the labeling now. The circle has radius 1 is x, so that's 1, this is 1, and this is 1. The other circles have radius r. So that means this is r, this is r. And then now we don't know. This I have no clue, so I'm just going to call that x. And that is basically this distance right here. So I'll squeeze in that x. And then this distance here, I'm pretty sure if I were to extend that line, this one right here, that goes all the way to the edge, right? So that is the radius of the largest circle. The radius of the largest circle is 2. This question tells me something very important, that the circle with center x passes through the center of the largest circle. Although it doesn't look like it in the diagram, this is actually the center of the largest circle because it has to pass through the center, the circle with center x. So basically this circle is passing through that center. So this is the center. So if I draw a line from the center to the edge like this, that's the radius. And the radius of the very biggest circle is 2, since it's basically the equivalent of the diameter of the circle x. So that means since from here to here is r, this must be 2 minus r. So let me put that in there, 2 minus r. Okay, I think I'm ready because this is a tangent point, so this is going to be a 90-degree angle. And using Pythagoras, I can get 2 Pythagorean relationships. One on this circle, one on that triangle, and one on that triangle. Okay, here we go. So we got r squared plus x squared is equal to 2 minus r squared. And then from this triangle, we get another Pythagorean relationship, and that one is 1 plus x squared plus r squared is equal to 1 plus r squared. All right. 2 equations, 2 variables, we can solve this. So let's expand this. R squared plus x squared is equal to 4 minus 4r plus r squared. R squareds cancel. Very nice. That means x squared is equal to 4 minus 4r. Factor out the 4, we get 1 minus r, and then take the square root, and that's going to be 2 times 1 minus r. Don't need to worry about the negative because x is representing a distance. Okay, so now let's expand this before I substitute the value for x. It's going to be 1 plus 2x plus x squared plus r squared is equal to 1 plus 2r plus r squared. The r squareds cancel, and so do the 1's. So that's very good. So all we are left with is this. Now let's substitute in the value for x. So 2 times x, which is 2 times 1 minus r, and then x squared, which is 4 minus 4r from here. And then this is equal to 2r. Okay, let's put everything on one side that does not have a radical. So that's going to be 6r minus 4 is equal to 4 times 1 minus r. And then let's just square both sides. We can divide through by 2 first. Makes it a little bit simpler. So that would be 3r minus 2. And now let's square both sides. And when we do, we will get 4 times 1 minus r here. And on this side, we will get 9r squared minus 12r plus 4. So this is 4 minus 4r is 9r squared minus 12r plus 4. And the 4's cancel on both sides, and then we get 9r squared. Adding 4 to both sides gives me 8r is equal to 0. Factor out an r, and I have 9r minus 8. So that means that r is either 0, which obviously wouldn't make sense since r is a radius, or 9r minus 8 is 0. Therefore 9r is equal to 8, r is equal to 8 over 9. And that is equal to approximately 0.888. 0.888 in terms of the answer choices would be closest to 0.89. And therefore, number 24, the answer is E. Three real numbers x, y, and z are chosen randomly and independently of each other between 0 and 1 inclusive. What is the probability that each of x minus y and x minus z is greater than negative a half and less than a half? Let's draw the x, y, z axes and a diagram. This is, of course, the x-axis, and this is the y-axis, and this is the z-axis. Our boundaries, of course, are 0 to 1 for everything, so that's 0 to 1. This is obviously 0. Here's 1, and here's 1. Now we take into consideration our restrictions or conditions. So the first one is that x minus y is between negative a half and a half. And the second one is that x minus z is between a half and negative a half. So let's draw these. First, let's look at this inequality. So that basically would mean that y is less than x plus a half. And we can quickly draw that. X plus a half. So for example, when x is 0, we're really just looking at the xy plane now. When x is 0, y is a half, so approximately here. When x is a half, y is 1, so approximately here. And then we can connect those two lines, and let's do that. So here we go. So remember, we're just looking at the xy plane right now. Later we'll look at it with the z-axis. Now let's look at this part. That would basically mean that x minus a half is less than y. So again, let's plot that. When x is, say, a half, you're going to have a 0. So that's going to be approximately x minus y less than a half. So for example, when x is a half, y will be 0, so that's right here. When x is 1, y will be a half right here, and then connect those lines as well. So as you can see, we want the area that is in between those two lines, because y's got to be less than this, and it's got to be greater than that. Okay, that, it's a cube, so that's going to be extrapolated all the way to the other side. So that's the key in this question, that you've got to be able to figure out the three-dimensional aspect of it. So we have to connect this, so let's do so, all the way to the other side. So there we go, and then I join them all. So that basically means that we've sliced off a section of each side, as you can clearly see. I hope this is drawn in a way that you can see that. Now that part is actually pretty straightforward, because all I have to do is just really look at the xy plane, and I'll draw the xy plane here, let's say. And you don't even need that big of a diagram, just something like that is sufficient. And then really what I did is I just chopped off corners like this. And you can easily figure out the volume of that. So the entire cube or face is 1 times 1. And then I chopped off this guy and I chopped off that guy, because that falls outside of our boundaries that these inequalities create. So this one would be a triangle, 1/2 base times height, 1/2, 1/2, and 1/2. And then similarly, this is also a triangle, 1/2 base times height, with the base of a half and the height of a half. So this is 1 minus an eighth plus an eighth, which is a quarter. So 1 minus a quarter, so 3/4. But that is just the shape that basically is 2D. We want the 3D version. Well, the 3D version, to get the volume, all you have to do is just multiply by the height. And the height from there to there is just 1, because it's 1 on the z-axis. So you take that 3/4 and you just multiply by 1 to get the volume of that shape, and that of course just gives me 3/4. So this 3/4 is a very important part of the question. We'd be done if there wasn't another inequality. But we do have another inequality, and that is x minus z now has to be between 1/2 and -1/2. Okay, in the same way, let's plot this. So this gives me two equations. The first one it gives me is that x minus 1/2 is less than z, if I'm looking at that one. And then if I'm looking at this one, it will give me that z is less than x plus 1/2. And in a very similar way, let's plot those. So this time it's the z and the x-axes. So when x is 1/2, z will be 0. So that's going to be right here. And then when x is 1, z will be 1/2. So that's approximately here. So we just connect those from there to there, approximately like that. And then this one here, when x is 0, it'll be 1/2 for z, and when x is 1/2, it'll be 1. So again, we're connecting it like that. So as you can see, in a very similar way, we have chopped that into an area, and we of course have to just look at that section. So let me draw the same thing on the top. So that's going to be approximately here to here, and from here to here. And let's now connect those. So we're connecting it to kind of show what happens. So there we go. All right, so I think that's pretty decent. All right, so now we have to figure out what's going on. Well, the first part, right, we figured out was 3/4, and that's great. But now from that 3/4, I have to cut out these shapes. And this shape, this is one of the faces, along with this right here. I'm chopping that off. So I hope that makes sense. I'm chopping it off from that side, and I'm chopping it off from this side, because we can only keep what's in the middle because of these inequalities. So, all right, not a problem, right? You just take this and then subtract from it those two shapes. But it's not that simple. Why? Because those two shapes also have this part missing, as you can see there. So it doesn't become that easy. So let's rationalize this. The first thing, of course, was we take our 3/4, which is what we got. And then from that, we have to subtract something. And that something, of course, is this triangular prism, right? That's what this is. And there's two of those guys, so I have to subtract those two triangular prisms. So 2 TP triangular prisms. But before we subtract the triangular prism, we have to subtract this segment of it. This segment that is not part of the triangular prism. See what I mean? And that is actually a square base pyramid. Square base pyramid. So that square base pyramid, I think that's the most challenging part. I think most people can get to here, but then it becomes challenging as to what is this shape right here. So let's illustrate that. Let's talk about that a little bit before we do this calculation. So we have this triangular prism, right? Right there. And what we did was we take that triangular prism and we put it here because we have to subtract that from the 3/4. No problem. But there is a problem because we then have to slice that, as I tried my best to illustrate here in the diagram. And that's what this does. It slices that triangular prism. And when you do, you get left with this shape. Now, what is that shape? That is the square-based pyramid. As you can see, this is the square base, and the rest of it is in the shape of a pyramid. So now we can figure this out. So this is 3/4 minus 2 the triangular prism, the area is up here, the big one. That is the triangle, and then this is the height all the way down. It's the area of the triangle, which is 1/2 base times height. The base is 1/2, the height is 1/2. So 1/2 times 1/2 times 1/2. And then you multiply that by the height, top to bottom, which is a 1 in this case. Okay. Square base pyramid, this guy, which is where that slice occurs right there. Above the slice, we have to get rid of that. How do you figure out that area? Well, the area of a square base pyramid is 1/3 times the base times the height. So 1/3 times the base. The base is a square. That's why it's called a square base pyramid. And the dimensions of that square are 1/2 and 1/2. So the area would just be 1/2 times 1/2. And then the height is from here to here, and that is also 1/2. So that is also 1/2. So there we go. We have this question done. Now all we have to do is just figure out that math. So that's going to be 3/4 minus 2, and that looks like 1/8 minus 1/24. Okay, so 3/4 minus 2, that is, get common denominator, 3 and 3, 3 minus 1, so 2/24. And therefore this is 3 minus 4 over 3 over 4 minus 4/24. And that looks like we can just get a common denominator. Multiply top and bottom here by 6. So that'd be 18 minus 4/24. That is 14/24. In lowest terms, 7/12. 7/12 is the answer. I encourage you to, and I'm being serious, get some Play-Doh. And Play-Doh, or sometimes it's referred to as plasticine, you can get these at any kid store, toy store, and then just make shapes. And then take a knife and cut through them. And I promise you that will help you, because sometimes it becomes very difficult to visualize it. Or if there's some computer software, perhaps that might be even better. So 7/12 is the answer to number 25, and that would be B.